Hi, well, good afternoon, everyone. Thank you very much for coming. One of the themes in our conversation afternoon is about preparing your media ready for Firebase things and preparing for failure. So there's a good example of not expecting something and it goes wrong. So that cost us 3 minutes. I hate to think what that happens when you've got 200 terabytes of media and you haven't prepared for failure. So it's a good example. So thanks for coming. We're going to talk about bridging the gaps in file-based workflow. And what my attempt to do is, with quite a limited amount of time, is to follow the pathway of file-based workflow from ingest right through to the final delivery, and just sort of look at what the issues and problems are across that pathway, and start thinking about, well, how do we measure these issues? What should we be looking for when we plan our file-based workflows in today's technology? So to introduce you, my name's John Harris. I'm from Route 6. We're going to do a quick little introduction to Route 6. I put a brief little resume up there for myself, only to demonstrate one of the key things is understand the management of change. I've certainly been through a very massive change from early days of transistors to the first implementation of digital video, from tape to files to obviously the migration of technology to IT-based systems. So obviously now we run on standard computers and we use gigabit and Ethernet networks to actually manage our distribution signals. So there's been quite a major change in going on, and understanding how to manage change is a very important part about managing file-based workflows. So quick summary of who Route 6 are. We are a reseller. We set up in 1997. We're just 15 years old now. I've put some key elements that happened throughout our history. But probably some of the really interesting things for us is the growth in demand for support. The way we do our business now, in that labor and that is being outsourced significantly. We're also working in very hybrid environments now. Typically, you don't just buy a Sony edit suite or an Ampex edit suite. For those who can remember who Ampex are, we tend to build much more hybrid environments. And the need for support at a single telephone number to cover all those elements has been really a big expansion for us in that area. In addition to that, we felt the need to develop training, and this is a really interesting one for us. With the move to file-based and obviously more to IT-based, we're sort of starting to work towards a drag and drop community who completely understand the software, the IT infrastructure, but have actually lost the basic essentials of understanding video and audio, technical specs and elements that we have to still pay very much attention to. So we developed a lot of new training courses for introducing video 101s, audio 101s, understanding QC, understanding color, that we really do need to know about if we're going to deliver broadcast programs, or indeed any form of quality program for any form of medium going out there. So it's intriguing to see that change in training status go on as we move forward. So Route 6 has variable groups within it. We have our support group. We just talked about the expanse of support that's going on. There's also obviously a diversity of customers now, whereas traditionally we would class ourselves as a broadcast account. We're now doing the educations, corporates. We recently built a big sell-up for Arsenal Football Club for their broadband. So there's a real wide variety, and I think that represents the spread of media thanks to the file-based workflows available. Our sales department have changed in the fact now we represent significant wide variety of products. But the key is understanding how to integrate those products and how we can get them to communicate with each other. So you can see the range there, which will link into our file-based workflows in a minute. In addition to that, we have our integration, and I showed those elements up there. Really, again, traditionally we built MTV's post facility up in Camden. That was very much Avid-based, it had a SAN, but it was very much BNCs and SDI video and Canon XLRs, etc. on the system. Now we're building 10 gigabit fiber infrastructures or gigabit Ethernet infrastructures for actually moving and managing our media around. And then finally, an unusual element for us as a reseller in that we developed our own technology. And what we are finding today is the fact that every installation is a unique and customized installation. So the need to have program scripts, generate templates to transform XMLs, we'll talk about these things in a minute, has become really, really critical. So we're developing tools to actually help enable technology to integrate and communicate with each other. So quick roundup of Route 6. I don't want to spend too much time on Route 6, and we'll get down to the main element, and that's recognizing file-based workflows. Before I do that, though, let's try and understand what a file is, because a file is a very complicated environment. And quite often, we have sort of the laptop terminology. Well, it plays on my laptop. What's the problem? Why is that? And we need to start understanding why that's not a valid reason to look at a file. So let's break a file down. So first of all, a file has a video element. And that video element contains, obviously, the core video compression system. So we just talk about compression, we talk about H.264, MPEG-2, MPEG-1, Windows Media 9. So you have a wide variety of compressions. We have an infinite variety of settings to set them up. But we also have to deal with a lot more stranger anomalies in there. Aspect ratio. In TV, we deal with 4:3, 14:9, 16:9, maybe 185. In file-based world, we deal with infinite aspect ratios. You'll go 320/40, you'll go landscape, portrait, etc. And we need to understand that. Frame rates, completely variable. So often today in file-based workflows, I'm bringing in YouTube footage, mobile phone footage. They could be at 12 frames per second, they could be at 6 frames per second, they could be at 60 frames per second. I've got to deal with those elements. Frame sizes are variable. Pixel types, we have to deal with square pixels, oblong pixels. It all gets very, very confusing in that area. And then probably one of the biggest things that really kill us at the moment in broadcast TV is Gamut. And the big problem with Gamut is we obviously have our broadcast standards, our 601 and our 709, as we call those standards. We know exactly how our signal should behave in that environment. But when we bring all these unusual mediums in, we're dealing in completely different ends. We have full range, restricted range, RGB, 422, 411, etc. in the systems. And we've got to learn how do we deal with that variable gamut so that the picture looks the same on our output device at the end. So there's a lot of issues there. So we haven't even reached the first layer of what a file is yet, and already we've got a great deal of complexity about how we deal with that file. So that's the video. We equally have an audio layer, and the audio layer obviously again equally has the same complexity. Sampling rates, different compression types, different number of channels, etc. on the system. Now we've got our video and audio, we need to think about, well, how do we link those two files together? We obviously want to play them in sync. And this is where the element of multiplexing becomes a really key service. You'll often hear about video on demand, and you have very different approaches to multiplexing for video on demand to deal with buffering for managing the audio playback. You'll hear about transport streams, we'll hear about DVD multiplexing. And actually what's becoming very appropriate for us in the broadcast world is we start dealing with OP1A and OP Atom. These are the MXF standards that are actually very critical for managing acquisition and obviously managing our post-production and our deliverable formats. So we need to think about how they represent our audio and how we have to deal with that. Quite often we apply traditional video terminology into this file-based world. But traditionally, if we want to record 8 channels of audio on our DigiBeta, we would just arm the 8 channels of audio buttons and press play and record, and it would go across the SDI video signal. If we want to do 8 channels of audio in a file-based world, well, we have to make sure the codec supports that. We have to use a transport stream multiplexer to do that. And then we have to think about how we're going to patch that audio to cope with those elements. So it actually gets a little more complicated. File-based workflow doesn't mean it's easier. And that's something a lot of people take away, think, oh, file-based is it's just drag and drop. It's actually a very complicated environment. So we haven't really reached the point that people really understand what a file is at this moment. And that really comes down now when we apply the wrapper. So what the wrapper does now is it takes all of that information, that video, that audio, that multiplexing, and it presents all of that information as a single file and enables you to then actually, the computer to deal with that file and recognize how to play that file back or how to decode that file. So typically when you consider a wrapper, you'll think of QuickTime, you'll think of AVI, you'll think of MPEG, you'll think of OP Atom, OP1A onto those systems. What's interesting about wrappers for us is their metadata elements are fairly restrictive. Clearly they give me all the metadata that gives me all the factual information that relate to that file, and that's great. Quite a lot of them now contain a timecode track, and there's a chance to add in a little bit more information on there. So what gets very interesting now is metadata, and we will talk about metadata as we go through the presentation. But what we need now is we need advanced metadata, because it's metadata that gives us our automated file-based workflows. So we can go one more layer, and this is like a graphical representation of how to perceive this as a file, but we can then go in what we call a container. Okay? And this is where we start talking about MXF. And what's interesting with us with MXF is now not only do we have the ability to embody that wrapper inside that container, we can now wrap and encode metadata in our own scripts. So you're going to hear things about XML sidecars. We talk about Xdcam, P2 with their XML, when XML is pretty much the standard for metadata. You're going to hear about, obviously, the DPP deliverable standard that has production metadata embedded in the MXF. So this is very, very important that we have a standard and the means of interchanging metadata throughout the system. So an interesting example of this is Xdcam. So just to allow you to understand the complexity, so Xdcam is an MPEG-2 video compression. It has PCM audio. It's multiplex through transport stream. It's wrapped in an MPEG-4 wrapper, and it's placed in an MXF OP1A container. So getting to know and understand the grips of that is great. The only really good news about that is it's an industry standard. And because it's an industry standard, we can always deal with it in the same way. What we do have to be careful, though, is, as with all industry standards, there's room for interpretation. So don't think a Sony Xdcam file is the same as a Canon XFF file, or it's the same as somebody else's file who all say they're Xdcam native. There's normally something that catches you out that you've got to be aware of. So just be warned on those things. Cool. So hopefully you all know what a file is now. Let's carry on and start thinking about our file-based workflows. So we're going to explore this little map through our systems. And as you can see, there are 5 areas that we're going to talk about. So I'm going to take you through this map bit by bit. And I'm also going to try and bring in some sort of current issues that occur today that, despite the fact that we've been presenting file-based workflows for 5 years now, there are still some very basic elements that are really causing problems in the marketplace and we don't seem to be able to get a grip on. So we're going to go through ingest, we're going to look at storage and the architecture of storage. We'll talk a little bit about post-production. We're going to talk about the deliverable mechanisms, and we're going to have a look at the DPP spec in a very brief way, and then we're going to talk about that management layer, that asset management layer. So let's begin with ingest. So funny enough, the first thing I always think about on ingest is archive. Now, that may seem a strange one, but we've got to think about where do we create our masters. And we've got all sorts of issues with ingest and what goes on here. With ingest, typically we're coming from a file-based source. It could be a flash card, an SYS card, P2 card, etc. And the whole purpose of that medium is that it's reusable. We want to get the media off of that medium, put the media onto another device, and then release that card to go on elsewhere. Now the problem with doing that is we need to think about what our medium is, how we do that. And when we start thinking about that on-set production or how that material comes in, one of the golden rules that we always apply to this, and there are many people in this audience I can think of who will equally confirm this, is that if you don't have 3 copies, you don't have an archive or a backup. And we also need to think about what those copies are. This is the one area that's causing us still so many problems. And again, I think it's people's expectations and their experiences with their laptops that lead them into this way. We have several productions who've gone out there, they've shot, they've probably spent £10,000 on their production, they've got all their media, they've copied it off their cars, they delete their cars, and they put it on a single FireWire drive that costs probably £200. And that FireWire drive has failed, and then they phone up and they start shouting at me, and I just say, I'm really sorry, but you're a fool if you've done that, and I can't really put it any other way. You've got to take this seriously, it really is important. You know, we say 3 copies. Typically, you're going to have a RAID set, and we're going to talk about disk RAID a bit later on. But really, you know, you want to have a RAID set. You want your distribution set. That could be on FireWire. That's absolutely fine. But actually, ideally, we want to get to an LTO tape. You know, that's probably going to be our most reliable mechanism to do that. Obviously, when we traditionally use tape, we always had that tape. That was our big backup master. So we need to get that discipline back that we still need that backup master. You'll be amazed how much this is still a current problem today. And you know, I've recently had another production on a single FireWire driver less than 3 months ago who've lost their entire production. So please do take that seriously. So let's carry on with ingest. We've talked about archive. And this is when we start bringing in the first elements that we have to consider with file-based workflow. And that's we've got to think about automation. And one of the things that we've done so far is we've played traditional video-based workflows into our file-based workflows. We've basically just mapped our file-based technology on top of a video technology. And that's not really taken advantage of what we can achieve with file-based automation. First of all, we want to be able to pull all our cards into one bucket, and we want to automatically ingest that. When we choose how we ingest, we want the system to actually understand and recognize what our editing format's going to be and what our deliverable format's going to be. If we get this right at ingest, so ingest could be creating a new file standard, creating our archive. If we get it right there, the time and money saved later on down the stage are significant. So one of the things we have to think about is where we now invest in time and resources to actually save it. That model and that Gantt chart across that is very different for a file-based system than it was for a video-based system. So automation will constantly come up as a theme as we go through this, because that's the benefits that we get from there. We need to think about offline and online, and this comes in many forms. We're having to deal with a lot of files that are coming in that are non-broadcast standard. There's no time code, they're different color spaces. How do we bring those files coming in? Typically, we're talking about very high shoot ratios. We look at the reality TV, and we can be dealing. We have a production at the moment, 120 to 1 shoot ratio going on in the system. So how do we bring that non-time coded media in? Well, the ideal way we'd like to do it is we'd like to bring that in and transcode that into a new master file format and let that new file format be our master. It'll be time coded, we'll be able to refer back to it, and the beauty is we'll be able to relink back to it to actually do a conform once we've done our offline version. Because at 100:1 shoot ratio, we really can't afford that much storage, at online resolutions. So the process of offline and online is still very important. We need to think about how we can relink to our offline material and what our best procedure is. So again, getting that right at ingest is critical to the system. Not only can we do that, we can also add other functions on it. So one of the things I was going to do now is play a short little video to you. I got permission from Talkback Thames, who do Escape to the Country, and they use an application called XM Pilot. And what that does, it means they're able to log actually with the camera on set. So I think this is just a really excellent way of demonstrating putting the investment up front and how much time saving that can be by getting that right. So we'll just play this.
XM Pilot changes the way post-production works. It turns a 2-day long log into a 2-hour job, almost automated. In fact, the only job our loggers now have to do is check the footage to see that it's all been shot right, because the logging process is effectively wiped out.
The first time I saw XM Pilot was at IBC in Amsterdam, and I instantly knew that there was an opportunity to use it on Escape to the Country.
XM Pilot is an end to paper log sheets. XM Pilot connects to your iPad or iPhone wirelessly from your camera. This transmits video, time code and information of which there and then you can log that clip. You can sort it into categories, you can do specific labels, good takes, bad takes, whether there might be an issue with light, any information that will benefit post-production, you can tag to that clip there and then.
What this workflow allows you to do is capture all of your logging on location in a very simple and straightforward way and record that with your video clips, and then when you're back in post-production the whole ingest process becomes very smooth and quick.
So recently on our Aston Martin shoot I got hands-on with the iPad and the way in which the data is stored and logged onto the iPad through the camera makes our job so much easier and it completely eradicates the need for logging.
The iPad writes the information onto the cards. Once the cards are brought back into post-production, all that information is clearly labelled so you know where, when and how it was shot, and even to the extent what take the director liked the best. Instead of trawling through tapes like years ago, or even nowadays shooting onto cards, you've got no kind of reference other than a bunch of numbers. So XM Pilot turns numbers into user-friendly information.
Okay, so I just think that's just a great example. I mean, obviously that product's associated with the Xdcam range. There are obviously lots of login solutions out there. But that investment up front, putting all that time up front, created massive savings in the whole post-production process. So ingest is really, really critical to actually make all your savings. Everything else will flow better if you've planned your ingest and understand your pathways going on. So I just really like that as a great example of that. So obviously, once we've ingested, we've now arrived finally with our media, sat on our centralized storage. And in this scenario, we really start talking about tiered storage. And we have to think about this in very different ways again. What we're trying to do is get the most efficiencies out of our storage we possibly can. And our tiered storage is really down to performance. We have this collaborative online storage. Typically, this is your Xsan, your Unity, it could be your Facilis TerraBlock, your DDP, or your EditShare. That's your online environment. But that storage has a responsibility to enable multiple people to work together, collaborate together, and actually have that media online in real time at all times. It's expensive by default. It has to be to cope with that. Therefore, we want to make sure that the media sat on that storage is absolutely being used in that application. If it's not being used for that application, then we then demote it. We demote that media into what we call nearline storage. Nearline storage tends not to have that performance. It's budget level on the storage, but what it does, it enables us to get fast promotion or demotion of that media through that tier storage. And of course, we take our third element, is actually we don't need to touch that media for a much longer period of time, and then we actually demote it even further into our archive, and that typically becomes a tape-based system. LTO tends to be the favorite. There are various formats of LTO in that we can have big libraries of LTO, or we can have single tapes of LTO with LTFS. So we can, even if we're not into a big library and we really want to follow our traditional videotape workflows, we can almost map those using LTFS as a single tape with a barcode that says, right, that is that project sat on that tape, and we can do those elements. So archive doesn't have to be complicated. It's just the disciplines of preparing that through that. So tier storage, we just talked about those elements on there. We talked about the cost and obviously the relationship of cost based on the performance and what the requirements are of the storage. And then one last element I do want to put in here, and this may seem an unusual one, is that we need to prepare for failure. So this is an interesting one in that in the budget process we have, and with the size of the media and the size of the storage, the cost for us putting in true disaster recovery SANs in this environment is just not feasible. Nobody will pay for them, etc. So we need to think about, well, how do we cope with failure? Quite often, we've actually recently had another major post house just lost their entire SAN. And it took them, over 5 days to bring that back up and bring all the media back online. They had to bring all the media back in again. But the production company needs to come and says, okay, we're happy with this, it's unlikely to happen, but we need to prepare for that. So how do we prepare for that? Well, there are certain maintenance things we can do. We should have hot spare drives. We need to think about where our sources of failure are and how we can back them up. And there's a lot of preventative maintenance that most of these SAN systems provide to us now, which can tell us and view the performance of the drive and pre-warn us if we start seeing a deterioration in performance. The reason why we do that, and again it's back to that laptop mentality. A single disk drive comes from a manufacturer today, and we have the mean time between failure of probably about 5 years. We don't really expect a drive to go wrong from that. So we have that first early failure period. That's pretty much ironed out by manufacturing. Then it arrives in your laptop, and you would probably hope that would last you 3 to 5 years. You probably may not even experience a drive failure. And that's quite valid for a single drive. The problem is, in our SAN environments, we have multiple drives striped together in one set. So if I take my ISIS 5000, I've got my 24 drives in there. Each one of those drives has an MTBF of 5 years. That doesn't mean it takes 5 years, but there's only going to be one failure. So now I have to take that 5 years and divide it by 24. So now I'm into, a fifth of the year. So every 5 months, roughly, I'm actually expecting a drive to fail on me. So I need to be prepared for that, and I need to think about, if that drive fails or if this system goes down, what is my backup plan? How do I prepare and move my production forward? I think it's always worth, if you're taking a production into a post house or whatever, actually having that conversation, being self-prepared for that, because when it does happen, then you know how to get around that issue and get moving very quickly, rather than all sit there and panic on what's going on. So do be aware, drives fail. They are not a perfect technology, and you can expect that. So unfortunately, we've got to briefly go through this due to the timing on those things, and I'm appreciating, we're doing okay. So we've got our post-production now, we've got our editing systems. Obviously, you know, we have various editing systems out there, obviously Final Cut, Avid Media Composer, Adobe Premiere on the systems. And what's very interesting, again, if we've got our ingest formats right and we've created our post-production editorial master, moving between applications in that scenario becomes very, very easy. We've seen Adobe with their Creative Suite, with all the After Effects, audio plugins, etc., moving backwards and forwards the Premiere timeline in relative ease. And it's, you know, a really great system in doing that. Avid equally have the same system. They developed the AVX plugin strategy. I can move in and out and around the timeline and watch external applications update their effects within their timeline very, very easy now. So there's some new products out. There's a high-end compositing systems like Ion Fusion that connect directly into the timeline of the Avid. And that AVX and that plugin architecture works very well for us. Final Cut, obviously one of their great strengths was always that QuickTime codec affairs. That QuickTime was very easy to track around any application that ran on the Mac platform. And that was always a very early strength for them in the early days. I don't know if anyone remembers Media 100, but that was a great compositing tool, etc. And that worked really well. And that, a lot of that was down to the QuickTime codec. So those elements go across. So plugin architecture is actually very important to us. It allows ease to move media around different software systems. It keeps it simple, and it's kept simple because that ingest, we got it right. And that was very good. And we need to be able to search that information. So that ingest allowed us to search and find our files and go through that. So we've got our storage, we've archived our media, we've created our program, we've moved between multiple applications, whether it's compositing, Sparks, or whether it's audio systems. We now have, you know, a real ease of moving that media around because our ingest was correct. And now what we want to do is we want to deliver our file out into wherever our distribution method is. So let's talk about delivery, because this is obviously becoming a very big subject this year with the announcement of the DPP spec out there. So delivery, what do we want to try and do first? Well, if we're delivering a file, we need to ensure that we have done quality control on that. And QC becomes an interesting area. We talked about automation, and there are a lot of file-based systems out there today. We have Tektronix Serify, VidChecker, and Terabaton, who are able to do full analysis of that file. And they will analyze that file, obviously, for the structure of the file, but they'll also analyze the file for the traditional technical specs, you know, video levels, audio levels, loudness, etc. So they will check all of those elements, and at the end of that, they will give you a report. With automation, we can actually call up those tools, get that report, and change our workflow according to whether we passed or failed that process. Some of these systems equally also have error correction in them now. So they will fix color errors, they will fix loudness errors in the systems. And again, we need to plan from that. One of the elements we do need to think of, though, when we do QC, is we need to plan the time for QC. Traditionally, QC is you put the tape in and you play it and you watch it and you've got your tech waveform scope on there and you'll see the output. So it was a real-time process. When QC first came into the marketplace, we were typically looking at 5 times the duration to do a QC pathway. That clearly isn't feasible in our normal production places. That's actually improved immensely now. There are render farms, etc. that we can do. But we're close to recognizing that a QC file-based pathway is actually a real-time pathway through the system. However, file-based QC will only analyze the technical elements. It won't tell you you've got the wrong audio track. It won't tell you you've got a spelling mistake. You know, it won't tell you that's the wrong scene. So visual QC still becomes very, very important. And when we look at visual QC, we have to, again, approach that slightly differently. If we do visual QC on our computer monitor, it doesn't show us the potential errors. And there's a lot missing. Obviously, the Gamut's completely wrong. We could have interlacing issues that we're not aware of because our computer monitor is a progressive display, so it could hide those errors. So we need to return our file back to SDI video. And the reason why we want to do that is because we want to get it back to a true TV standard, so we can do that. So typically, we're looking at every file for a full QC pass is probably twice real time before we actually deliver that file out into the system. So once we're ready to deliver that file, we obviously want to think about our network delivery, and we obviously want to deliver across the internet. There's obviously significant savings in delivering across the internet. So we need to do secure deliverables, we need to do high-speed deliverables. So there's a lot of technology out there now today with Aspira, Signient, who actually enable you to actually deliver files securely. They give us the robustness of the internet connection, and what's more important, they give us the full bandwidth of the internet connection. Quite often, as we extend our pathways further with standard FTP or TCP/IP protocols, our bandwidth abilities will reduce immensely just due to the nature of TCP/IP. What the Aspera systems do is they actually open up that pipe and then they enable us to take full advantage of that pipe no matter what the distance. And equally, they give us reliability. One of the most horrible stories is you're in your hotel room, you've VPN'd in, you're doing your FTP upload, your VPN stops, 90 minutes into the transfer, and you have to start again. So it's great that with these systems, we can actually just pick up from where we started from. Finally, the standards for broadcast deliverable. And I think I just want to break away a little bit and just talk about DPP. Is everyone aware of DPP standards and the new broadcast deliverable formats? So what happens is the DPCs represents the consortium of UK companies. And what they've done is come up with a specification about how they want to receive files. So it's great now for us as manufacturers, we all know one standard about how to generate their files. But clearly we're trying to push automation further. So the broadcasters not only do they want to receive the file, they want their systems to be able to pick up the automation to manage the distribution of that file within their facility. So with the DP, you'll hear about AS11. So this is the MXF standard. And you'll also hear about the DPP shim. So if we look at an MXF file, we obviously have our video essences, remember our previous drawing, but also we have that element of metadata come in there. So the DPP have advised whether they want to do an AVC 100 for high definition, is the codec standard, or they're doing IMX 50 for standard definition. It's fixed frame size, it's fixed color sampling, so we know exactly where we are. The audio is PCM. It needs to be 24-bit PCM audio, so be careful of that. And then the key is they want this production metadata inserted into the file. So they've approached that in a couple of ways. Obviously, that standard has been released out to the manufacturer, so obviously as manufacturers, we're trying to implement that standard. In addition to that, DPP have also delivered an application that enables you to deliver your AVC file to that and type in the metadata that's going on. So we've had the first really big successful distribution using the DPP with the America's Cups. There's a lot of stories about that. In addition to that, there are obviously XML sidecars where we can't actually do the MXF bedding. So that's a separate XML file with the metadata. So just give you a quick example. This is a metadata schema that we use on our product. So this allows us to take our file, enter our metadata, and then encode that file to the full DPP spec and move on from there. So we have a standard about how we can do broadcast deliverables. We understand about QC. We need to plan our timing up on the QC systems, and we need to just start delivering these files. And that's going to start accelerating for us very quickly now. Okay, we're nearing the end, hopefully. We've got a few more minutes. Asset management is obviously a very, very large conversation, and it's quite interesting with asset management is, what does that term mean? It's so broad, it's so wide. Really where we're getting to at the moment is that there is no one asset management system that does everything. We're really moving into the world where we have micro media management systems that communicate with them. That means they have an open architecture and that they allow us to interchange metadata and actually interchange job queues. So we could have an asset management system for our archive, we could have an asset management system that manages our production workflow, and then we could have a full media management system that manages our library. Quite often, those will be different devices. And the key thing on those is to work out how they communicate with each other. Asset management obviously gives us a lot more tools available to us. And I'm going to talk about some future tools in a minute. But obviously, we have the ability to remote log. We don't have to be in the edit suite. So we can log, add metadata, mark in and out points, etc. through a standard desktop device. And they also manage the next layer of archive, that promotion or demotion throughout the system. Always a lot of questions, and happy to take questions on this later on. So in summary, going through our bridges to fixing gaps in Firebase workflow, automation. We need to take advantage of automation. Planning up front is absolutely the key to this. So if we can get our ingest right, we can get our metadata right, the automation that flows on from there is amazing. We need to consider the timing of our elements of our post-production. That timing is different now in different areas, and we need to plan and put those systems in. And we absolutely have to prepare for failure. We have to have an archive, we have to consider what happens in those scenarios. So an interesting project that we worked on was Life in a Day project. So this was the Google movie that asked the YouTube community to tell them what they did on the 24th of October 2010. So that was a project. They had a 5-month production window, and that project had 81,000 clips come in from 60 different frame rates with multiple codecs, from web cameras to mobile phones to security cameras to HTV to etc. onto the whole systems. So we had this wide range of thing. What we did with that is we structured a very strong logging process. We actually used a product called CatDV in that one. We logged all those clips in. CatDV was able then to give us XML metadata, which enabled us then to select the clips that we wanted to move forward. With that XML metadata, we were then able to transcode those clips into our editorial master format, which was a DNX 36 24 frame for offline. Clearly, we had to go for an offline-online process. What we were able to do, though, is we were able to publish the metadata into the Avid Media Composer so that our Avid Media Composer metadata matched our CatDV metadata. So suddenly we had this open architecture allowed it to communicate. Once they chose the clips, they ended up with 4,500 clips they wanted to use from the movie. Most of that original source material was non-time coded. There was no time code on it. So then what we did is we then actually created a cut list of the clip names, and then we retranscoded those to the online resolution and then relinked the whole process again. So because of that process, we were able to deal with 81,000 clips to generate, a 90-minute movie in a 5-month schedule. Automation was the only way that that could have worked, so that was very important. So finally, just to wrap up, we do need to talk about futures. I've done that whole summary and I haven't even discussed the cloud, which is obviously a very hot topic at the moment. So if we look at our future, if we look at our traditional tape-based workflow or whatever, we obviously see lots of couriers, lots of shipment of goods, etc. We need to remove all that, but we don't want it just to ship to the same places through the internet. Actually, when we start looking at that process, we recognize very, very quickly the idea of centralizing all those services becomes very appealing. And obviously we see the reduction in complexity of that diagram to actually put those here into the cloud. So obviously now we're seeing products like Foreseen, who are now giving us, internet-based login systems, etc. It means anyone can log in and do that. And we're seeing a big uptake in that arena at the moment. But these systems obviously deal with proxy resolutions. They cannot deal with online resolutions. And it's not a restriction in the software. It's really trying to understand what the real problems are. When we say cloud, we're going to a computer farm up into the internet area. The cloud-based could be our own private cloud, or it could be the internet-based cloud and system. But the reality, it has the same physical restrictions as we do in our local SANs. We talked about our tiered storage earlier on our online storage and our ability to actually cope with high bandwidth solutions. That issue exists exactly in the same cloud. It's not just our internet connection that causes a problem, it's actually our bandwidth right through down to the disk drives that each one of those servers going on. So there's some new challenges coming about at the moment in time, and there's some new thinkers about how the cloud will centralize all our services. So I think today is looking at proxy-based editing for the cloud, make sure that XML data drifts back down to us, and then carry on from there. So that pretty much concludes where I am. I think we're heading very quickly into the next seminar. So what we're doing, I'm actually based on the Route 6 stand over there, and we've got some product specialists as well. If you do have questions now, what we'll do, we'll close this one down. If you want to come over, you're welcome to do so. I will do a last pitch for Route 6. If you come over, we have a scratch card competition, so you can win a pint of beer or a media composer, and there's actually a main competition to win a complete turnkey edit suite. So thank you very much for your time, and good luck. Cheers.